Today we are going to do a training about Wi-Fi because we consider it's an important topic that we need to cover. And of course, I think a lot of you are really interested in that. So why is this training happening? Well, because we are building the homes of tomorrow, and therefore we are building the best network experience ever. And the network is crucial for the homes of tomorrow because it makes everything connect together. And wireless is, in my opinion, even more important because the end customers will evaluate the quality of the installation based on what they use more, which is the Wi-Fi. So from their perspective, the Wi-Fi would be the most important thing for them. Also, this training is to provide you with the tools to make exact quotes based not only on experience, but also with science and with some fundamentals that we need to know. And of course, it will ensure that we will have less support calls. We will provide a better service, and the end will be the smiley face, the more happiness from the end customer. So in this training, we will cover the fundamentals of a well-designed wireless network and, of course, how to do it. Are different. They are used for different objectives. Wired is for stability, and wireless is for mobility. Wired uses physical ports to connect to a switch, but wireless does more or less the same, but the communication is done by using electromagnetic waves connected to an access point. So different approaches, different equipment. So first option, it will be always wired. And if there's no other option, then wireless. And why is that? Well, and as you can see in this image, the environment is so important, and for wireless is crucial. Wireless is suited to obstructions and attenuations that comes from the materials that build the house. So I'm going to show you a practical case, a plan. Here in this image, you can see that there's a plan of a house where you can see different rooms and different access point places around there. And you can see, depending on the building material that is in the plan we have selected, it can affect to the experience. So this is why it's so important to plan the location of the access point and also the transmit power and everything that we will cover later. Building materials are crucial to take into account to provide a good experience. Now, let's start by explaining some networking fundamentals that maybe you already know. Is a recap. When designing wireless network, we need to start from the end, which is the end customer, the end point, and then going backwards. Now, the starting point is the power that will be received in the devices, in the end devices, mobile phone, tablets, smartphones. What is the magical number that we need to achieve? Well, the closer to zero, which in this case for a 5 gigahertz band will be minus 65 dBm, and for the 2.4 gigahertz will be minus 60 dBm. That will be a really good power received in the end device. Materials, and why is this so important when planning a wireless network, a wireless deployment? Well, as you can see, different materials provide an amount of signal loss depending on the composition of that materials. So I'm going to show you an example. For example, here in this plan, we have two different places. It seems like a living room and then a terrace, for example, and we have put an access point there. We can see that the glass window separates the two different rooms. So you can see in the color how strong is the signal. Now, what changes if I change the material of that window and I change to, for example, to a drywall? Well, you can see that it affects a lot to the signal. And I go back and forth, and you can see the difference between that. The reason is because different materials affect in a different way to the signals. And how is that possible? To transmit the information, and these are easily affected by the environment. These are frequencies that we use in our daily lives. So what are the frequencies that the access point use in particular? They use the microwaves. And inside these microwaves, we have two bands of operation. The 5 gigahertz band and the 2.4 gigahertz bands. Both of them have different features, and the difference between them is the 5 gigahertz band will have a higher throughput, which is faster, but has a less coverage. And on the other hand, we have the 2.4 gigahertz that has a lower throughput, but has a better coverage. I'm going to show you also an example in a real life, in a plan. In this case, I have put a plan with different rooms and a 320 access point, place it in the middle. And this access point operates with the 2.4 gigahertz band. What happens if I change the operation of the access point and tell the access point that he needs to operate in a 5 gigahertz band? You can see here is the difference. If I go back, you can see the difference. The 5 gigahertz covers less area, but provides a higher throughput. So when it comes to plan an access point deployment, what do we need to do? Well, as we have different bands that have different capabilities, to have a plan to 2.4 gigahertz and have another plan to 5 gigahertz will be more complex. And also, as the placement of the access point will be static, it's only in one place, one precise place, we cannot move it around. We need to do something to standardize these two bands, the operation of these two bands. So what do we need to do? The solution is really simple. It's reduce the 2.4 gigahertz in 5 dBm. So we are reducing the transmit power of this band. So the result will be that both bands cover the same area. So that will be the perfect starting point to plan the channels, transmit, and so on. Gigahertz. We need to recap some crucial key points that we need to know when it comes to designing the Wi-Fi. So we will talk about the different channels of operation and how this technology works. Wireless fundamentals, 2.4 gigahertz. Because of the technology of the 2.4 gigahertz bands, this is built to have 11 channels to choose from, and always these channels, the channel width is 20 megahertz, the number that you can see there. 20 megahertz, it is the width of the channel. But what is the problem? Well, as you can see, they overlap. There are 11 channels, but overlap. But why is that a problem? I'm going to put you an example. Imagine that you are listening to an analogic radio and you select the frequency, and in that frequency there are two songs being streamed at the same time. So you will hear one song sorry, I click on the other one. You hear one song, then the other one, then the previous one. So this problem, it's called co-channel interference because both are selected in the same frequency. Another problem that can cause is this one, the adjacent channel interference. The same. Imagine that you are listening to a song, but you put your dial in the middle of two songs. What will happen that you will not hear it very well. So the same happens with the electromagnetic waves that operates in the access point. Exactly the same. If we are selecting, for example, channel 1 and channel 2, as they are overlapping each other because they are next, the problem is adjacent channel. What happens if I select channel 1 and channel 1 again? The same, they overlap. So what is the solution to when it comes to designing the Wi-Fi? Well, as we want to avoid these two phenomena, we need to only select the 3 channels that does not overlap, which are channel 1, channel 6, and channel 11. And the wide will be always the same because this technology doesn't allow to do any other changes. 20 megahertz wide and channel 1, 6, and 11. There's no other option. The technology has evolved, so we are going to explain the 5 gigahertz band. This technology, of course, is better. First of all, we resolve the problem of having overlapping channels because this technology does not have any overlapping channels. All the channels are one next to another, so this problem disappear. For example, in this example and in this training, we are not to going deeper and explain the DFS channels. If you want more information, I can send you some links to articles, or we can have another training. But to simplify things here, and we are talking about wireless fundamentals, we are going to focus only in Unit 1 and Unit 3, which we are going to cover later. So 5 gigahertz bands. We have plenty of channels that we can use. Of course, it's the same width as the 2.4. We have 20, so the width is exactly the same. What is the result? That, of course, we have 9 channels to choose from. Remember, in the previous, in the 2.4, we had only 3 channels. And in this case, we have up to 9 channels that does not overlap. So that's a way more, of course. Does it mean that we need to design our Wi-Fi only based on these 9 channels? Well, not really. I'm sure that you are familiar with the concept of bandwidth. So the bandwidth, the bigger the bandwidth, of course, the more information that is able to transmit. So the same happens with the channels, the channel width. The wider the channel, the more bandwidth it has, so more information it's able to transmit. So well, probably you can think, okay, so if I want to have faster network, I will need to have the biggest channel. Well, be careful. Shows you exactly the same that we were talking about previously. We have different columns, Unit 1, Unit 2, Unit 2 extended, and Unit 3. We are going to focus on Unit 1 and Unit 3. As you can see, depending on the channel width that you select, we will have different numbers of channels available. So in 5 gigahertz and only in 5 gigahertz, okay, we can group channels together to provide a wider channel that can allow us to transmit more information. So depending on the channel width that we select, we will have a number of channels to choose from. For example, if we select a width of 20 megahertz, which is the smallest, we can have up to 9 channels. But what happens if I select 40 megahertz? Of course, we will group both 36 and 40. For example, in this example, we will group both together and we will have a channel double its size. But of course, as we are grouping, we can select only 4 channels. We had 9 and now we have 4. But what happens if I group these two together also? I do a group of more. It results into 2 channels. Why is this so important? Because we need to know that if we do changes in grouping the channels, it will affect to the way that we plan. This technology that is used to group channels together has a name, and this name is channel bonding, which is grouping channels together to provide a bigger bandwidth. So the bigger bandwidth you have, more speed. So summing up this graphical that we have seen as compares as a resume, as a sum up, we have 20 megahertz wide, plenty of 9 channels, and these are the numbers. If we select 40, of course, we reduce the number of channels. And if we select 80, we only have 2 channels to choose from. Okay, so how do I know which one I have to choose? Which one, if I need to channel bonding or not? This access point. For example, imagine that you are going to use only one access point in the house because you are building a really small apartment, and you calculate with the plan, and yes, you think that only one access point is enough. So well, you can choose 80 megahertz wide because you have only 2 channels. You can select only one and you have plenty of speed. What will happen if you had 3 access points or more? Well, in that case, as you need to combine these 2 channels, 80 megahertz will not be the best solution. So the best solution will be 40. And what happens if I have it's not a common scenario, to be honest, but if you have a lot of access points all together in the same place in a crowded zone, well, you can choose the 20 megahertz, but it's not as so common, as I said. So for you to remember, many crowded zones with many access points, 20. The preferred solution or the preferential option or the default option that we will choose will be the 40 megahertz. And in specific cases where not many access points are going to be placed, then we can choose 80 megahertz wide. Okay? So this is how will look the 2 bands. Imagine that we select the medium, which is a 40 megahertz wide. We will have 4 channels to choose from. And of course, the 2.4 gigahertz band doesn't allow us to have more than this, only 3. An advice that we give you, and to simplify you the things when it comes to designing the wireless network, is just associate channels together. For example, imagine if you are going to set up an access point and you put that this access point needs to operate in the 2.4 gigahertz in channel number 1. So you do a rule and you say that always the number 1 is going to correspond to 36 of the 5, and the same happens with the 6. 6 is always going to be with 46 and 11 with 151. This is like a tool or a rule that you can use, and it's a tip to simplify your installations and the way that you configure the access points. Now, once we have decided what are the channels we will use, the non-overlapping channels, what is the width of the channels in the 5 gigahertz band, now we need to know where to place and how we can combine these channels together, because we have 3 options. And how can I put one access point that has the channel number 1 next to another one that has number 1? You need more information about this technique. It's called honeycomb. It's like the bees. And in this case, you can see colored the different channels that you can combine together. For example, here in this example, you can see that you have one access point configured to be operating in channel 6. So next to it, we cannot have another 6 because we will have problems with the channels. We need to have or 1 or 11. So this will be the deployment. What happens with the 11, for example? Well, 11 cannot have another 11 next to it. So it will only have 1 and 6. Exactly the same happens with the 5 gigahertz bands. It's exactly the same. In this case, I choose the 20 megahertz, so you can see the same, but it's more or less the same. 36 only with 48, 44, 150, but you cannot have the same channel together. Okay. So in a practical case, in a real world scenario, this is what we will have. A plan with access point placed, and let's say like a draft of where these access points are going to be placed. Then you have to select the only 3 channels that are not overlapping, and of course, if you place one access point in the 6, you need to put 1 and 11 around and not again the 6. Exactly the same happens with the 5 gigahertz. If you select one number, you cannot put the same number around because it will cause problems in the Wi-Fi network. We have explained like the theory part. We are sure that you know the theory part. Now we are going to cover what do you need to know to do a good quote and a good installation. In this image, you can see we have 4 access points in the 20 series, of course, 4 access points, and depending on the requirements, on the expectations that the end customer has, we need to quote one or another, of course. It's not the same 4x4 multi-user MIMO that 2x4. Of course, it's there are different features, and of course in speed, and of course in features like the hardware itself. The 520 outdoor has a specification of IP55, which the same model 520 indoor doesn't. So it's important that we know the features. When it comes to specifications in the websites, in our partner zone or in the manufacturer specification, It's so important that we know the difference between the physical data rate and the advertised. What is that? Well, the physical data rate is a number that is given by manufacturers, and is of course is in a world, in a perfect world, where there's no attenuation or obstructions. It's just a name that tells us what's the maximum of speed, for example, that this hardware can reach. Of course, as you have learned in this training, this physical data rate needs to be placed in a world, well, in the environment where this is not perfect. Okay, so what we need to do, what we need to know is that this number suffers different attenuations on the speed. Why is that? Of course, the device capability can have this speed, but what are the numbers of a stream at the same time? Also, what is the channel width that we have selected? In 5 gigahertz is not the same selecting 20 as 80 wide of the channel. Also, the distance is not the same when you connect a remote control next to the access point, or if you place in 3 rooms there. Of course, interferences and stuff like that. So, and this is important for you to know, of course, to know how to quote, and of course to prepare the end customer of the expectations. So they expect what the device can really achieve and not other things. So that's why it's so important to know physical data rate and effective data rate. How is this access point built? How is this hardware? This is so important, of course, because we need to know where to place this access point. We're going to see a graph, and these graphs, you can find it in the manual. If you look for the specifications, you see, for example, this access point here. I'm going to select, yes, this access point here, or this one. You see how is it placed and what is the capability of streaming. You can see that it's in the front. So what is the what is the lesson we learn from this? That all access points are designed to be mounted in the ceiling, and this is so important for you to know because of the hardware, the build, the how they are manufactured. They need to be mounted in the ceiling. What happens? That some people doesn't really to put them in the ceiling because they think that they are not aesthetic or well, it doesn't fit the design. We have a solution for that because we know that this is so important for you, and we have a great tool to use, and it's this in ceiling mounting brackets. These are compatible with the X20 series, 520, 320, and 920. And it comes with 2 different models, the small one and the large one. And you can see there in the difference in the website. How is it mounted? It's so easy. You can see here in this image that you cut the plasterboard, you place the back box, you put another tool into the access point, pass the cable, connect, and you have this all set up. And the result is really aesthetic. You can see that it fits, it's like a speaker with a grill, and it's really it's so easy to do. When it comes to placing the access point, also an important tip that we give you is please be aware that in the installations reserve 1 meter from the light fixtures, the LED panels, HVAC grills, speakers, just to be secure that it doesn't interference with the performing of the access point. And we honestly think it's because of the lack of knowledge on that, is that a lot of people put or install the access point hidden or in the closets. Why is that a problem? Of course, because of the environment. We have wood, we have clothes, we have mirrors, glass. There are several materials that can affect to the performance of this access point. And I'm going to show you a real case, for example. In this case, we have a plan, and there is a wireless access point put in a closet. You have a really close look at the transmit powers and the waves. What happens if I change the location of this access point? Anything has been changed. Just put the access point not in a closet, but in the main bedroom, for example, just an example. What happens? Well, there's a huge difference. As you can see, even in the color, you can see everything is blue, almost dark blue. If you put there are more spaces that this access point can cover. So that's why it's so important when you are doing the theory part that you have done everything. Please be consistent and place the access point in a good location. Let's say misunderstanding on the way that access point work is the number of devices that this access point can manage to provide a good performance. So before knowing the number of access point required, it's important to consider the maximum number of devices that we will be connected to this access point at the same time, simultaneously. Of course, access point with Wi-Fi 6 have the ability to have the beamforming, which will help to provide a better experience. But you need to be aware that access point can manage up to 40 devices per access point. Why is this so important? A pool that you want to put an access point because this is a special area that needs coverage too, because people are going to have parties, for example. So this is an example of a villa with a pool and a barbecue around there, some sofas to a chill out place. Okay, if you have the plan, you see that actually there's no interferences around there because it's an open place. So you think, okay, if I put one access point and I check the speed or the coverage, -50 is really good because you remember that we had -65, -70, so -50 is a really good number that we can achieve. Okay, think of this example. Imagine that you have around 30 people there, 10 people having a look at your plants, 20 people in the pool, and you have a total of 60 people around there in your house and in the customer's house doing a party. 60 people means that you can even have like 90 wireless devices. Consider remotes, consider smartwatches, consider smartphones, tablets, PC. Do you have enough with one access point? Actually not. So you will need 3 access points. Why we are advising this? Because you can actually have this case in your installation where the customer complains that they don't have a really good coverage or a really good experience when they are searching in the internet, streaming music to the speakers. And you can think, okay, how is that possible if I have put one access point and everything is empty around there? There's no attenuation, there's no obstructions. This is the landscape. Well, think about this. This can happen to your installation to not to be as well as it should. So one tip that we give you is when it comes to doing some quotes, of course, you need to take into account everything that we have explained earlier, but be sure that take in mind that 30 or 40 devices are the maximum of devices that can be connected to provide a good performance. Of course, it can be some places where only one access point is enough. Imagine a living room where the house is not going to be crowded. It's going to be used like, I don't know, like 20 people, 25. Well, it's a good number. It's not a problem. But this is especially important in places where they are going to be so crowded, like doing parties or doing big meetings with a lot of people. This is so important for you to know, and it's something that, well, people do not really know or take into account. So the result of a good experience or a good planning will be have 3 access points, the outside or the outdoor model. Of course, as you have learned, adjust the transmit power, adjust the channel, adjust the speed. And if you do that, well, end customers are going to have the best experience possible. They will be so happy. And this is our final goal at the end. So to sum up everything that we have seen today, these are important key points. First, ask the maximum number of people connecting to the wireless network simultaneously for specific zones. Second, the devices are phones, but also smartwatches, tablets, Apple TVs, PC, remotes. There are a lot of devices that need to connect to an access point. Third, one access point can manage maximum up to 40 devices. Of course, advertised speed is not the same as effective speed, and it's because of that, of the environment and the wireless nature. Never cover or hide an access point if you want to provide a good solution and to be professional. Instead, use an in-ceiling mounting brackets to do so. We can send you also the links for these devices. And last but not least, plan with the plans. This is so important and will help you to provide the best network or the wireless experience possible.